Last time in the workshop I was working on a Pioneer KE4300 radio cassette player. I fixed a clicking tape deck and got to the bottom of a broken tuner circuit. We left off after discovering a torn ribbon cable and a broken and unobtainable LED tuner display. And last time I managed to get all of the broken ends of the ribbon cable out of the main board. Now to deal with the other end. Preserving the old PCB is a bit of a priority, so I don't want to take any big risks. So I'm going to chop this ribbon cable up into smaller segments, so I can just take them out one at a time. You can't make an omelette without breaking a few eggs, they say, as long as I don't knacker this board. Changing for the monster tip. Being careful not to melt this push button assembly. I'm hoping for no fights here. Looks like the tip's a bit clogged. Just give it a bit of a poke. That's better. Well, so far so good. We've only come out with one damaged pad. We need to fix that. Just scrape a little bit of the solder mask away. And to fix it I'm going to use some tin copper wire, some thin stuff, a little drill bit and a hammer. Just want to make a loop around the drill bit. Then you need to sort of centralise where the wire comes out. Then I'm going to lift it off. Then I'm going to make the next hole just slightly further up. It's a bit hard to gauge, but this loop's too far away, so just keep pulling. Just draw it closer. It's about right. Pull the drill bit out. Then I'm just going to flatten it. Just trim off the excess. Just put a little bit of solder flux on here. A little goes a long way. And just add a little bit of solder on here, just tin it. Place our new pads on there and just line them up. And snip off the excess. So I need to cut 28 pieces of this wire about this long. Unfortunately I don't have a clever way to speed this up. I'm going to tin the ends of these little wires, easily done, just dip them in some solder flux and then dunk them in a solder pot. It's pretty crude, but it is fast. Let's take one of the tinned wires, pop it in the hole and solder it. So that's the wire sorted, well, this end anyway. Put some tape over the top of this, stop the LED coming out, and just line it up. There we go. And just solder it up. I can peel that tape off. Then we just put the green LEDs in. Might be a bit of a fiddle, trying to get their legs lined up. There we are. I've been using this Blue Tack substitute, whatever Crit Stick branded stuff. It's an absolute godsend soldering stuff in like this. Very helpful. Try and get these lamp legs through here. There's only any legs sticking out of these, so I have to make sure the solder runs down. Should be okay. Then just put this cap over the LEDs. There we go. Now to deal with the missing display. We don't know much about the LED array apart from what's in this schematic. And what we do see is we've got 4 banks of 8 LEDs and their anodes are all common together. So we'd be expecting to see 8, 9, 10, 11, 12 pins. So we've got a bank of 8 pins here and another bank of 8 pins here. 7. It would have been an 8 there. We also have the common anode groups around here. If you look at the back of the display PCB, we can actually see that these banks of 8 are actually joined together. So that makes sense. My plan is to make a PCB design to mount some tiny surface mount LEDs. And we can see that these 0603 packaged LEDs are pretty much the right size. So I've used KiCad to lay the PCB design out on. I've actually laid out 32 of these surface mount LEDs, and I've grouped the anodes into little groups of 8, and each bank goes to different anode pins. The other sides of the LEDs are connected to the individual cathode pins, these 8 here, and same underneath. The end groups are connected to vias on this side. If I just show the bottom copper, you can see that the bottom cathode pins go to this bank and this bank over here on the right, and these top cathode pins service the 2 pairs on the left. We can see what this looks like on the 3D viewer. And this is going to be quite a good fit, I think. Simple board. Not a lot to see really. And if we're happy with this, which I am, we can close that and we can generate our manufacturing plots, which we'll use Gerbers or Gerbers. I'm only including the layers I need to: front copper, back silkscreen. There's no front silkscreen, so I don't want any writing where the LEDs go. Front mask, bottom mask and edge cuts. We're good to go. So I'm going to generate the drill files and then plot them. Done. So we can see our manufacturing plots here. All the files we need. Just go back out to that, and then we just need to zip it. Compress to zip file. And done. I'm not normally shy etching my own PCBs, but this design's quite fiddly, some very fine traces and vias, so I'm going to hand over the manufacturing to some professionals, and a good choice is PCBWay. You'll find PCBWay online by just going to PCBWay.com or clicking on the referral link on the video description below. They offer a full suite of services, including PCB prototyping, PCB full assemblies, flexible PCBs, high reliability durable PCBs, CNC machining and 3D printing. But in my case, I just want a low volume PCB. So we'll go on to quote now. We're just going to upload our Gerber files, which are just up here. And all of the details of the boards being picked up by the software. You've now got some options to choose from. You can have them single pieces or in a big panel. The size has been picked up already. I only want a few pieces. It's 2 layers. I'm quite happy with FR4 material. But I would like a thinner PCB. Instead of 1.6, which is standard, I'm going to go with 1mm. Because this thing's fairly low profile. Because it's a display PCB, I'm going to make it black, so you don't see anything behind the filter. And pretty much everything else is fine. Just click on calculate. Choose your destination. And apply it to the settings. And then save it to the cart. And we're not making weapons. This is fine. And as a thank you, PCBWay have kindly provided a voucher giving you $10 off any order over $30. You'll find the voucher code in the video description below. Check it out. Simply enter the coupon code PCBWay-MendItMark into their website and take advantage of this cracking little deal. And in classic YouTube time, they're here already. Well, they've come very well packaged and they built them pretty quickly. And here they are, in the flesh. How exciting. And that looks like a fine functional replacement to me. And I tell you what, I couldn't drill holes that small. Not lined up with the other side of a PCB. Not a chance. So let's have a look at these LEDs. Very small they are. See if I can tell which way round they go. Just do a diode test across them. Aha! So the line is the anode. Because I reckon I'm only ever going to make one of these, I didn't buy a solder paste stencil. And these pads are really too small and close together to do a nice job just blobbing it on with a syringe. So I'm just going to apply copious amounts of solder flux onto this, and then draw the soldering line over with some conventional solder. I want to keep the amount of solder on each pad to a minimum, so I'm just wiping it off as I go. Then I'll lay the LEDs on one at a time, making sure they're the right way round. This is going to make it rather sticky. Now, I don't know if that's going to help or if that's going to make the LEDs float around. I'm not sure. Just peel some off. Just going to tweeze these into place, making sure the little spots are at the top. I'm going to use this hot plate for the soldering, because I think hot air soldering might blow all those LEDs off. It's set for 240 degrees, but as I'm using lead solder, I don't need to go anywhere near that, so 200 degrees will be better. Just place these on here just to sort of melt these ones on. Might just need to hold this down a little bit. It's getting more seated the right way. That looks good. Right, the next day to going the other way up. It's a fiddly job. These are so small. Let's just get these stuck down. I think that's okay. Dots at the top again. Back on the hot plate with these. Okay. And now the last 8. This flux is causing me trouble. Look at them all going in the wrong places. It's the surface tension that does it. They get pulled away from the pads sometimes. Now I can clean the flux off. So time for a quick test. Common anode over here. Just run along here. Make sure we've got every light working. Perfect. And the next anode is here. Oh, that's a mounting hole. This is another anode. This picks up on these cathode pins here. Perfect. And finally, this common anode here. Hard for you to see, but they're all working. Excellent. Now I'm going to put some legs on these, like this. They were flush fitting, so I'm going to have to do as best as I can. So I'm going to use some 22 gauge wire and just swage the end of it and snip it off to make my own pins. And just give it a little tap to seat it. And repeat until I've made all 20. Just tap them down so they wedge into the hole. Then solder them up from the other side. And just clip these heads off flush to the board. On to the next side now. Then lock these into place and solder them up. We'll just even these up and cut the heads off flush. So this is looking a bit more like it now. I just need to put the lens on. It should just clip on. Ah, it doesn't. Oh, I see. I appear to have got the hole spacings wrong for these little pegs. Oh well. I'll just snip them off. I'm a bit too committed now. Let's try it now. That's better. I will put a tiny spot of glue on each end just to stop it dropping off inside the radio. That would be bad. Well, I think you'll agree that's quite an improvement. I'm quite proud of that. Let's line the legs up. There we go. Like a new one. Oh, missed one. There we go. And we can have a little preview, see how it looks. Oh, I'm pleased with that. Oh yes. I'll solder this orange wire back on first, and then poke each one of these wires into the appropriate hole. This could take a while. And another little soldering job. Let's hope it holds up, eh? Should pull these knobs off so I can put it back in its chassis. If I recall, I have to slide this in. Just get these wires out of the way. It's pretty difficult to grab hold of. Just lift this display up a little bit. Just give it a bit of a push from behind. Not been very good to me. Oh, see, it's this board here. Well, now you've got this insulator, I need to put this card in there. Don't want to short the amplifier onto the chassis, do I? That's in. Let's screw this into place before I break any of my wires. Just put this retaining plate on there, whatever you call it. Fancy washer or something. It also clamps the circuit board down. Just whiz this nut on. Same on this side. I think this nut's 14mm and I don't have a long reach socket that size. So now we can just put the fascia on. Solder some of these grounds back on. These might be a nuisance to get on. They're both soldered to the same point. So there's one ground, then we've got the negative side of this capacitor. Will it all stay together? It will if I hold it. Let's push this back plate on. There we go. Pop a screw in there just to hold it. And another earth. It could do some more solder. If I had to take it off again, I'll add some more. Let's put the tape deck back in. Plug the heads in and the mechanism. Let's plug our test antenna in again, so that piece of wire and the ground. Let's give it a try. Well, we've got an LED there. It's not as bright as I was hoping, I'll be honest. Just put the knobs on here. Let's try and line this one up. Let's see how it looks then. Oh, can you see that? There's two LEDs on. Well, what have I done? At least it's tuning. You can hear activity. Oh! That's more like it. And it's picked up my test signal. 95 megahertz. Looks about right. What's going on with this display then? Just check the other bands. Medium wave. Long wave. Seems to be working. It's just the display's not right. Let's check the tape player. Check that's still working. Okay, well that's working okay. However, we've got no light on here. What is going on? Oh, that one's working. Oh, I've got problems with this display. I thought I was being a bit cocky putting a few screws back in. Luckily I didn't put them all in. Pull the tape mechanism out as well. Well, nothing looks bad here. It looks as good as it was when I fitted it a few minutes ago. These connections look alright. So it's the normal indicator that's not working. Tap receives a positive voltage through pin 28 and it's grounded through pin 25. So 28's on the end and that's 25. We got nothing. The other LED's on pin 27 and we've got a reading there. Have I got the polarity wrong? Check it this way around. Nope. Let's check them directly. Let's go directly to the back of these. That one's working. This one, nothing. Best to just whip it out, I reckon. I've got plenty of 3mm green LEDs, however this one's slightly shorter. It's been flattened off on the top. You might need to sand that back. Try and solder it sideways. I'll need to plug this back in to test it. And maybe the playback heads. Not vitally important for what I want to know. Just make sure this has got a good ground. Just clip it onto the frame there where the tape doesn't go. And try the sacrificial tape again. I need to hold it, don't I? But very pleased to see the light working. I was right about that. Let's eject that. Good. I also noticed this lamp's not on now. It was before. Just check we got some voltage across it. And we have 12 volts. Let's fetch the tape deck out again. Let's whip this out as well. Just desolder these holes. This bulb's got a little blue filter on it. If I can get that off in one piece, that's nice. Just needs a new bulb. Luckily I keep a stock of this sort of thing. The physically smallest bulbs I have are these ones, and they're pretty close. Still slightly longer. Let's see how we get on with this filter on here. It's very pale blue if it's not green. I don't know what colour it's supposed to be. To be honest, I don't think it's going to do a great deal to the colour of this. It's a slight hue on it. It's about as far as it's going on. Just poke those legs through. And bend it over. Grab these wires and cut them off. So that's good, we got the lamp working again. So what's going on with this display? You see stuff going on with the segments. The individual switching's fine. Just do with the common anodes. Look at that. Still tuning in. 95 megahertz. As we saw before, there's actually 4 groups of 8 LEDs. The cathodes are all joined together from each bank, and we can see those switching correctly. The problem appears to be with the anode connections. Either I've soldered a short into here, or there's a problem with this chip. Okay, using the diode test on the multimeter, we have the common anode pin there, and we can see it's all working as it should. Next anode is down here. Same again. Lovely. Swap the leads over. This one here, this is where we're seeing the trouble. We're not seeing any signs of that misbehaving. So I need to get to the bottom of this board again. So I am unsoldering these again. And I did promise I'll put a bit fresh solder on it next time. Well, I didn't want to be doing this too many times. That's how I broke the ribbon cable last time. I can't avoid this one. So the anodes are supplied from pins 1314 and 2324, and it appears to be these two pins which have the problem, so at least I can compare them to these two. So diode test from ground. So this is pin 13.75 volts, good. Okay, similar. Oh, nothing. And that one looks okay. So now it needs a Pioneer PD4003. So I'm back on the world's biggest marketplace for an obsolete Pioneer chip. There are a couple for sale at least. But this radio's starting to cost me a lot in parts. Well, I'm in too deep now. This time I'm going to use these soldering tweezers with the massive tips. But like before, I'm going to slide this palette knife underneath, not much room under this one, and try and desolder as many pins as possible. Work my way along. Add a little bit more solder as well. Just helps get it all flowing. That seems to come off better. No torn pads. Just suck that excess solder up. So here's our replacement one, looking exactly like the old one, apart from the legs need bending. And just like last time, I'm using the old chip leg straightener to bend the legs. Now just line the legs up. Looks about right. Just start soldering two corners, just to hold it in position. Watch I don't bridge two together. That's better. That's now both custom chips replaced on this radio. Not having much luck. I suppose they have lasted 40 odd years though. Well, I need to plug the cassette deck in for a quick test. See if this display works properly now. Yes, it does. I'm happy with that. So now I can get it back in its chassis, hopefully for the last time now. Just gently lift this over. Nothing broken, I hope. Just insert this card, stop it shorting out. Oh, that's annoying. I'll see if I can repair that in situ. That wire's too short to fix, I need to pull it out. See if I can fish the broken ends out. Well, I got one. I think that's them all. Just see if I can get the desoldering tool in there. Nice. Look, I've still got that little jig. But I'm not firing the solder pot up just for one wire. Just tin the ends. Hopefully I can just poke this through. That should do it. I feel I should get this secure before this ribbon ends up breaking as well. There's only so much flexing this lot will take. On with the little nut. I did say I'd add some fresh solder onto these to tidy them up. So, here we are. Let's pop a couple of screws in the back, stop this thing flapping all over the place. Let's put the antenna back through its proper slot. This little clamp also makes a ground connection onto the shield of the aerial cable, not just keeping it still. This one, on the other hand, is just a clamp. Keep it tidy. And back in with the tape mechanism. Four screws for the cassette deck going in, and one for the amplifier board. Now on with that iconic fascia. Let's put these knob caps on for my delicate little fingers. Time for the assembled test. All looking as it should. Display's working beautifully. There's my 95 MHz test signal, working great. Because I've changed both the tuning chips in this radio, I probably need to recalibrate the tuner. Now this radio is supposed to pick up FM as low as 87 MHz. Just going to wind this all the way down to the bottom. Just adjusting L3 on the front end. It tells you this in the service manual in a roundabout way. There we go. Now the other end, we go all the way to 105 MHz. Takes some getting to. That must be it. Now we adjust TC3 over here. There we go. Then check we can still get 87 MHz. Oh, it's thrown it out a bit. Slightly over. I ought to save this station instead of winding the knob. There we go. Go back to 87 again. And store that as channel 1. Does it tune though? Yes. Channel 5. This is looking good. Back to channel 1. Perfect. Now I'm going to tune it to 90 MHz, get the maximum output. There we go. No surprise, they were already right. Same again, but at 104 MHz. We can cheat a little bit. Channel 5, wind it back. Now adjusting TC2 and TC3. Again, I don't think that needed changing. Next up is medium wave. Bottom end is 515 kHz. I'll store that. I'm going to change to AM modulation now. 515 kHz. Adjust this one here. Okay. All the way to the top, 1.63 MHz. Look at that. Perfect. Finally just calibrate long wave. Bottom end is 145 kHz. That's not bad. Top end's 295 kHz. I don't think I need to mess with that. That looks pretty good to me. There's nothing left now, just to put it back together. Let's get these two nuts somewhere there or thereabouts. Put the washers on. And pop the fascia on. So I think there was a washer on here. There must have been. Because I don't know where else it's come from. These little skinny nuts are always hard to start the threads. There we are. And for the last time, these little knob caps. That's it.
On BBC Radio 2.
Now that radio turned out to be more work than I imagined, but it was fun. Catch you next time.